So as the speaker told you, my name is Guillaume Vallin. I'm responsible of production and research department of l'IDEA in France. And today I will speak about the sunflower seeds production and how the P20 we are using could simplify your sunflower production. So first, a few words about sunflower and what are the specificities of this plant for production. Then the experimentation we managed during 2 years with the P20 and some results. So how we characterized a sunflower male. And finally, the agronomic answer we can develop, we can use in production to improve the production depending the result we have with the P20. So first, sunflower is an allogamic plant, mainly an allogamic plant. It means that the pollination, the fecundation, is the crossing between a plant, the pollen of a plant, and the oval of another plant. But it's also autogamic. It means that we can have an autofecundation because both sexual organs are in the same flower. The answer for the male and the oval for the female. So production seed, sunflower production seed is when we are producing seeds, we are producing hybrids. It means that it's the crossing between a female plant and a male plant. To avoid the autofecundation of the female, we are using a CMS gene to avoid the production of the pollen. This is a production field of sunflower. We can see we have an alternance of female and male plants, which provide the pollen, and female which will produce the seeds. In production field for sunflower, we have the quantity of male is between 16 to 33%. For seed company, the fecundation or the pollination is the most important thing for the seed production. Here you have two different pictures. The first one with bad fecundation around 15%, and the second one with a good fecundation around 95%. What are the consequences for the market when you have this bad fecundation? It's not only the seed quantity, but it's also the seed quality. When you have a bad fecundation like that, here you have an heterogeneity of the seed size, an heterogeneity of the TKW, the weight of the seeds. So you will increase the percentage of waste, and it will be bad for selling. Also, when you have a bad fecundation like that, it could be due to bad pollen quantity in the field. So you can have purity risks if other pollen are fecundated your female. And purity risk is really a problem for the market. Also, some studies are showing the impact of germination when you have a bad fecundation. This studies is mainly for rapeseeds, but maybe for sunflower it could happen also. So I saw that the pollination or fecundation is very important, but which factors are impacted this fecundation? The first step is the pollen production by the male in terms of quantity and in terms of quality. The second step is the transport of pollen by vectors from the male to the females. Vectors are bees for sunflower or other external insects. This transport could be affected by the vectors, but also external factors like climate. And the last step to have a good fecundation is the germination of the pollen and the compatibility between the pollen of the male with the stigma of the female. So in this presentation and with the P20, we will analyze the male characterization in terms of pollen production, quantity and quality. So why my department bought this P20 instrument? It's for these characteristics. So you told us the characteristic of the P20. For the production research, it's really easy to have this kind of instrument. First, because it's a portable tool, so it's easy to use directly in the field to manage the experimentation. Then it's a resistant tool. We could have high temperature, dust during the season, and the experimentation is under this temperature. The analysis spend around 1 minute, so we can characterize a large panel of male during the day, and we have a good reliability on the results. So now, what parameters we want to characterize on the male? The first one, concerning the quality, we will collect some answers during the flowering, and we will use the P20 algorithm to measure the viability rate of the pollen produced by the answer and the aberrant cells fraction of the pollen. Concerning the quantity, we will collect closed florets before the flowering, we will crush them, and with the algorithm, we will count the number of particles inside the florets. And in parallel to this measurement, we will count the number of florets every day to have the global production of pollen by parental line. Climate have a huge impact on pollen quantity and pollen quality. A collaborative study made in July 2023 shows the effect of high temperature on pollen viability in terms of germination and in terms of pollinic tube length. That's why during 2 years we made a trial under multiple climatic conditions with multiple dates of sowing to integrate this climate effect on and to measure the exact behavior of the lines. Just an example. At the right, you have the maximum temperature during 2023 experimentation, and you can see that you have some peaks more than 40 degrees. It's not Switzerland, it's Toulouse. Even 50 here. So it could have a very huge impact. The sensor was directly in the sun, that's why it's 50. So we can have a huge impact on the parental lines. So we developed a model to integrate this climatic data and to measure the exact behavior of the parental line, even if there is a different climatic condition. This is the results for viability. So in y-axis you have the pollen viability rate. In x-axis you have the aberrant cells fraction. And the dots, the points, are the males we tested. It could be males from production, it could be males from research. And we have some positive and negative checks. They are chosen because of their results in production field. So the negative check do not fecundate the pollen, the female. So thanks to this result, we are now able to split our panel in different categories. High viability in the top here with a positive check, and also low aberrant cells fraction, an intermediate viability, and a low viability rate. Also, the aberrant cell fraction are showing us the susceptibility of our male with thermic stress. This is the result about quantity. We have the panel of male here and the particles per floret in y-axis. So we can see we have a huge variability in terms of quantity in our tested panel, from 20,000 pollen grains per floret to 80,000 pollen grains per floret. And to calculate the total amount of pollen production per day, we are taking the hypothesis about which is 125 florets per day. It's an average of all our tested male. So this is the final scatter plot, the final result, showing in y-axis the quantity, and in x-axis the quality of the pollen. And all the panel are showing on this scatter plot. The size of the points are the aberrant, the quantity of aberrant cells, so we can detect the susceptible male. With this result, we can detect the good males, which will be the first group, with high quality and high quantity. The bad males with low quantity and low variability. The susceptible males, which will be susceptible to thermic stress. And the rest is in the intermediate males. Is it okay, the microphone? So now, what can we do when we have this kind of results? For the group with high variability and high quantity, the production team can increase the quantity of female per hectare, because the males can produce enough pollen, enough variable to pollinate all the other female. So we will increase the potential per hectare of the variety. With the old techniques, it was not possible to do that at the first year. Concerning the second group, the intermediate variability or quantity, we will adjust the ratio between the female and the male, depending the fecundation we have in our production fields. Also, it's possible to increase the vectors, like bees, to transport more pollen, to fecundate better the female. Concerning the group with susceptible males, we will allocate the production field in stressless climate. So we will not produce the variety containing these males in south of Spain, in south of France, or in south of Europe, but in other climates, stressless, like in Switzerland, maybe. We will see production field of sunflower in just here. Also, it's possible to adjust the protocol of sowing to sow early the production field to avoid the period with high temperature. And concerning low variability or low quantity group, unfortunately, we asked to remove this genotype from the research to avoid a risky production in production department. To conclude, so sunflower seeds production is impacted by many factors. It could be climate, it could be vectors, and pollen is a very important factor to have good seeds in terms of quantity and in terms of quality. The P20 instrument can simplify the characterization of our sunflower males in terms of pollen production and stress tolerant. And with all techniques, it was not possible to do that just after the research program. And with this result, we are now able to develop agronomic answers to improve the potential of seed production depending the characterization of our maize. Thank you.